So we have seen a lot of things yesterday, like why do we need the C programming or why it's so important? Then how can we go to or how can we learn it in a step-by-step manner? So which are the what's the overview of the module? Then we started with the very first chapter, that is the problem solving. Okay, so in problem solving, in which all ways we can solve the problem we have seen. So three main methods are there. One is STLC. So while so what is STLC? Do you remember? So STLC, do you remember what it is? That is system development lifecycle, and for us that is software development lifecycle when it's the software as the product. Well, so when which are the different steps of SDLC? Do you know? These things are also important. Okay, so while working in an organization and all, or while solving the problems, so systematic way is important. Okay, so don't ignore this. Don't think this is something unnecessary. This is also important. Requirement design, code and test. Good. Okay, so requirement design, code and testing. So we will never jump to the actual solution or the implementation directly. So proper understanding of the requirements, then accordingly visualizing it, then implementing based on the design or the plan, then testing it with all the inputs and outputs. Okay, all the possibilities. So whether any loopholes are there or bugs are there, we are just testing it. So these are the different steps when that is the STLC. Okay, then we have seen the Polias rule. It's very similar to it, similar to the STLC. So they're also understanding the problem, devising the plan, carry out the plan, and then again just checking it back. Okay, like whether everything is fine. If so, then that is the implementation, like the finalizing the product. Or else, if something goes wrong, then again going to the first step, correcting it from there. In the code section, we prepare the yes, not the complete code. In the code section, we prepare the skeleton code, which means this is the outline code. Okay, so you will understand it when you do the project. By the end of the module, when you do the project, like what is skeleton code, what are the things, how to improvise it. So which are the things required? According to that, you are going to create a skeleton code first. Okay, so these are the things which are going to, which are need to be implemented in my program. And these are the types of functions which are required. These are the set of inputs required. Okay, so accordingly, we are just writing a skeleton code. Then testing purpose, that is like checking for all the possibilities, whether it's working according in the sense in an expected way, whether it's working or not. That is the testing. So that is the improvisation on the code. Then after the testing only, we'll get the final product. Okay. So the third method is algorithm. While coming to the algorithm again, we have three methods. That is, do you remember which are they? Which are the three methods with which we have done the algorithm yesterday? That is natural language, then pseudocode, and the flowchart. Okay, so this is where we started with the example, like which are the different possibilities of a solution. Accordingly, algorithms we have seen, and which is the best algorithm, that depends on the requirement, isn't it? So these many things we have seen. We just started with the solution or problem solving. The solution in the sense, using the algorithm, we just started with solving the problem. So the algorithm, we have written that using the natural language, and we have written that using the pseudocode. We have even written that using the flowchart. Okay, so these many things we have done yesterday. And till here, do you have any doubt? Explain the need of algorithm. Algorithm in the sense, like how can you reach to the actual solution? Okay, so I told there are different methods like the STLC and like the Polias rule. This is the third method of finding the solution. Okay, which means from where we can start. Okay, so if you don't have any idea of the programming, okay, if you are such a person, you don't know even not even one programming language, so you don't know how to write even with the syntax and or the in a programming way you don't know, okay, to write the things. So in that case, you are going with a very simple language, that's the natural language, like the English or your mother tongue, in which you can understand it in the better way. So you're just writing it down, which are the things, or how can I come to the solution? Okay, yeah, correct. It's the logic building. So it's like, how can you get the solution? So implementation part or writing the program is easy if the logic is clear. Okay. So I told like simple programs. For example, I want to find the sum of 1 to 10 numbers. Okay, I have the numbers 1 to 10. Then using these numbers, how can I find the sum? Okay, for each and every, like 1 plus 2 plus 3 plus like that, till 10, I have to find the sum. But how to find it? So that I should have a start of that particular solution. Then I should have the numbers. Okay, then like that, step by step, what are the requirements? Okay, then what are the things? So when it's the sum, then like addition, then there will be something to hold the actual sum. Okay, the final sum. So I should take a variable there. Then taking one by one number. So we will see such problems. So today itself, I'll show the same thing. Okay, to find the sum of 1 to n numbers. So basically, yeah, of course, not only for beginners, like this algorithm is very good thing or a very good thing to practice now. Why? Because when you have a very complex problem to solve, something like a very big project, okay, project will be having a lot of sections. It's not like a single program or one single file. If that's a project, a lot of files will be there combined together, compiled together. Then you will get a final output, just one output. Okay, so a lot of things will come. Okay, so in that case, you can just divide everything, you can just work accordingly. Then, if the step-by-step things are there, you knows like what to be done first, what to be done at the end. Okay, like everything will be clear before going with the actual programming. Algorithm method is, yeah. While comparing, algorithm is easy or it's better to understand. Like the flowchart and all, it's easy to understand. Okay, so as a programmer, like we are preferring more the pseudocode. Why? Because conversion of the pseudocode to actual program is very easy. We have to just add some syntax. Okay, so the how to do that we will see. So the thing is like, am I audible clearly for everyone? Okay, fine. So it's like the entire thing for the algorithm, basically what it is, it's the logic building. You're clearing entire process, like what to be done first, how it, the next step should be, what should I do there, which function, which syntax to be used. So what is syntax function under, we'll see later when it comes to the programming. So as of now, we are just practicing how to write it. So even for the beginners, this is very helpful. Okay, so first you are building the logic, then only you are trying to implement it using the program. So whatever whatever algorithms or whatever we are doing in today's class or what we have done in yesterday's class, you can just try the same thing when you start with the actual programming. Okay, so how to implement? So that is the next level. Implementation is the next level. Okay, so actually what it is to do the program, you should know how to do it, or the logic should be very clear. That's what we are finding through the algorithm. Okay, so is this much clear? Any doubt? We have to write, yeah, write algorithm. Algorithm, again, the natural language is one type of algorithm, flowchart is another type of algorithm, and pseudocode is another type of algorithm. Okay, you can choose any of this. Okay, so for the programmers, I told what is preferred is nothing but the pseudocode. But if you can't write the pseudocode in the beginning itself, then fine, you can go with the natural language or you can go with the flowchart. No issues. So whichever is comfortable to you, you can practice that first. Then you can switch on to the pseudocode. Okay, and then from the pseudocode to the program. Okay. So we will practice some more like the with all the or at least with the pseudocode and flowchart today. Okay. Any other questions? Shall we continue? Pseudocode in the sense it looks so. This is an example of pseudocode. Okay, so if I do little changes here and there, I can easily convert that to a program. Okay, so but the thing is like I can't actually compile or I can't get the output for this particular one. Okay, if I keep the same lines in my program, okay, I won't get it compiled. Okay, there it will show error. So this is not the actual program, but it can be easily converted to the program or something which looks like the actual program but cannot be get compiled. Compiled in the sense the process of getting the executable file. Okay, so that those things we will see step by step. We will see. So the thing is like in our program, okay, we can't keep the begin and end all. Those things are not allowed. Like why it's not allowed? It's not like maybe it's a command. Okay, but the compiler doesn't know these commands. Okay, so we are for our understanding, we are just writing the begin, end, and all. Okay, so this is for our understanding, but the system or the computer doesn't understand these things which are written here. So we can easily convert. So this is for our understanding. This is the beginning of the process, and this is the end of the process. That's all. Okay, so that's a pseudocode. In short, pseudocode is nothing but which looks very similar to the actual code, but we cannot get the output from that particular program. Okay, so it's not even a program, looks like a program. That's all. Okay, well, so we will go with the similar questions. So we have done just one, add two numbers. That was our first problem. Okay, similarly, we'll go with the next one. So do you have any other questions till here? Is that clear for everyone here? Hmm? Yes or no? Okay, good. So we have to find the algorithm, write the algorithm to find the largest of three numbers. And this is our problem now. So we have to first write the, so here also we will go with all the three, or we can just cut short it. Okay, so we can even go with just a pseudocode and the flowchart. Okay, so natural language, it's writing each and everything as sentences. So fine, we can write the pseudocode directly. Okay, so we will do only the pseudocode and flowchart. Okay, then again we will convert only to the pseudocode later. So first we will see the, okay, let it be pseudocode. So always remember we are going to write the step-by-step procedure, whatever it is, the pseudocode or the flowchart. So we have to start with the process. Okay, start with the solution. Now, what is required here? What is the requirement here? We have to find the largest of three numbers. Now, what is the requirement? We have to read three numbers. Correct. So, reading three numbers. So, now how can we read it and all? That is the next thing that comes while implementing. So, now our requirement is like using some function, we have to read three numbers. Okay. So, after that, what to do? Hmm? So, if it's the natural language, we can say that is like comparing the numbers with each other, isn't it? Okay. So when it comes as the pseudocode, okay, better I go. with the natural. Okay, I'll just show the difference there. Natural. Sorry for that. Okay, read three numbers. Then we can say like compare. So I'll just name it N1, N2 and N3. Then compare, how to compare it? First number. So if we can say the N1 is the largest, then how to compare it? N1 should be greater than N2, N1 should be greater than N3 also, isn't it? So we have to compare it like N1 and N2 first. So if that is true, generally we have to compare, okay, or if true, compare N1 and N3. Okay. So if this is again true, like comparing N1 and N2, that is fine. N1 is the largest there, and again N1 is compared with N3. If there also N1 is largest, then what it is? We can just do what? Okay, we can just display the result as N1 is the largest. Okay. So similarly, we have to again do the comparison. So if this is not right, then what it is? Okay, if this is not true, what it actually means? Comparing N1 and N2. So this condition is false. So what it means? Yeah, if this condition fails, that actually means what? N2 is greater than N1, isn't it? So if this condition is true, that means N1 is greater than N2. If this condition fails, that means N2 is greater than N1. Okay, so if the condition, so if false, okay, if this condition fails, then we have to compare. So what is the next step? So here itself, N2 is greater than N1. So we don't have to check it again. Okay, so we have to just check whether N2, okay, so compare, yeah, compare N2 and N3. Okay, so if N2 is greater than N3, so N2 is already greater than N1. Okay, if this condition fails, N2 is greater than N1, then we are checking whether N2 is greater than N3 or not. If that's also true, what it actually means? N2 is the largest. So we have to display N2 is the largest. Okay, again, if this condition fails, okay, while comparing N2 and N3, okay, so while coming for this checking, N2 is already greater than N1, okay, so we are comparing that with N3, and if this condition fails, what it actually means? Okay, that means what? N3 is the largest. So N2, which is already greater than N1, is compared here with N3. Okay, so N1 is not coming to the picture. Sorry, N2 already greater than N1, correct. So N2 and N3 only while comparing here. So N1 is already like to come here, what it is, this condition should fail. Okay, if this condition fails, that means N2 is already greater than N1. And that N2 is compared with N3. So if again this condition fails, that means next higher number will be the largest. So any shorter number, yeah, right. Okay, so in this case, N2, if it fails, that actually means, sorry, if this condition fails, that actually means N3 is the largest. Why? Because N1 is not even in the picture now while comparing. Okay, so I'll just do it like if true, then display. Okay, if false, display N3 is the largest. Okay, so that's our solution. So again, what it is, we have compared N1 and N2. Then if that fails, we are comparing N2 and N3. So if this is also not true, okay, so again what it is, okay, so here also we can do the same thing. N1 is greater than N2, okay, N1 is greater than N2, and we are comparing N1 is greater than N3 or not. N, uh, can we use else? Yeah, that's what. Okay, so here also we will do the same thing. If true, N1 is the largest. So while coming here, while checking this one, what it is, N1 is already greater than N2. Okay, so this N2 is not even coming to the picture while comparing these two. So N1, which is already greater than N2, is checked with N3. And if this condition fails, okay, that actually means again N3 is the largest. Okay, so the same thing while checking for the previous one also. Okay, so we found the solution. Like we know that N1 is the largest when it reaches, N2 is the largest, what is the condition? N3 is the largest, what is the condition? So all the possible checking are done. Okay, now what it is, we are even displaying it. So that's our solution. Now the fourth step is nothing but stop. Okay. So this is the natural language. Using the natural language, we can write it like this. Now we will, sorry, sorry for that. So we will do the pseudocode. Just improvising this. Okay, so start, let it be the same. You can even give begin, end, doesn't matter. That's for our understanding. So reading three numbers, read three numbers instead of that, I can just cut short this as read N1, N2, N3. Okay, I don't have to give and numbers, all those words. N1, N2, N3. That's enough. Then comparing. Okay, so to compare, I can just use the word if. Okay, so that is for the understanding again. I can just give it like if N1 is greater than N2. Okay, then this what to be done. Okay, so again, what I'm doing, again, I'm checking N1. Okay, so what I'm checking here, N1 and N2, comparing N1 and N2. So I can just replace this and with a greater than symbol. Whether N1 is greater than N2. That's what I'm checking. Okay. If so, I'm again checking what instead of this one, I'll just go with the replacement with the operator. Okay. So, or the symbol as of now, the operator does the operation. Comparing is an operation. Okay. So this is called as an operator. Okay. So this is again, we are replacing the words with the operator, or the in the previous case we were doing one expression. Okay, so instead of writing as n1 and n2, adding n1 and n2, storing in sum, we are just given that as the expression. Okay, the similar way we can just, instead of writing that in the sentences, we can just replace that with the operators. Okay, or we can write it in a better way, how we can give it in the program. So this also, instead of display, okay, so I'll just do it as print. So that printf is the common function that can I use operator in single line? And no. As of now, we don't know the type of operators and all, so we are not making it complicated. So without knowledge, so if you already have the what the knowledge of operators and all, maybe you can write the pseudocode a little more in better way. Okay, using the combining the condition. So this is one condition, this is another condition to be checked. So combining the conditions can be done using again the operators. That we will see later. Okay, so I'm just keeping it as simple. I'm not combining the conditions at all. I am checking one after the other. Okay, so this is like the basic level. Like I'm not making it complicated, keeping it as simple as possible. So this is the next condition checked. If that is true, then this is the thing that I'm doing. If this condition fails, okay, if this condition is true, I'm printing this particular line. Okay, if this condition fails, I'm just doing, so instead of false, if false, okay, so what I'm doing, if that is not true, I can just say else. Okay, so that is similar to the actual syntax or the words that we use in our programs. It's not words, it's the functions there. Okay, we won't call it as words. Okay, so these are something like keywords. They have some name called as keywords. What are keywords? And all we will see. So this can be used like for our understanding also we can write it if else. That's a very common thing that we use in our usual language or the colloquial language, isn't it? So this is for understanding. We are checking a condition. If this is true, fine, this is going to be done. Else, this is going to be done. So again, we are replacing that with the print. Okay. Here also we'll do the same. Okay, so I'll just, okay, let it be. Eh, Okay, it's like comparing this first. Okay, maybe the indentation. Okay, so comparing this first. So it's like if this condition fails only, I'm coming here. Okay, I'll give the solution for that, Ankush. So if this condition fails only, I'm coming here. So I can say this is the second condition to check. Okay, so I'll do it like else if this is true. Okay, if this is the first condition true, then again I'm checking another condition. Okay, if that is true, we are going to print it. If else, we are going to print it. Then if this condition fails, where to come? I'm going to check this condition. Okay, again I'm just doing if true. So instead of that, I'll just do print. Print into is the largest. Okay, then if that also fails. So here I'll give else. Okay, now is that clear, Ankush? Okay, so like this. So this is why the indentation is so important. That's easy for understanding. So I have given proper spacing. Now it is understandable, isn't it? Uh, New subclass under the main class. Okay, don't compare this with the C++ now. Okay, so maybe you know the C++. So classes and all, it's not there in the C programming. Okay, so class will come in C++. The way of writing there is different. Here, this is top to bottom approach, like step by step approach. Okay, that is like bottom to top approach. So don't compare. You will get confused. Okay. So this is like sub condition under this condition. Okay, I can say this is one another condition checked only if this condition is true. Okay, now the proper spacing are given, so it's more understandable. So is the pseudocode clear for you now? Okay, now this is the natural language from which we created the pseudocode. Okay, somewhat it's looking like a program, but it's like okay, okay. We will Anil, please wait. We will do the flowchart now. Then again, it's more understandable. Okay. So for this, we'll do the flowchart now. Okay, so somewhat it looks like the program, but it's not the actual program. Yes, that's why it's called the pseudocode. Okay, now the flowchart. So I hope you remember the flowchart, how it was done and all. So if you don't remember, these are the things that to be used. So the elliptical, that's where we start. Okay. So we need the elliptical. Start. So you can just have a look into the pseudocode, then it will be easier. Read N1, N2, N3. Okay, so reading the inputs. Then what we have to do, next thing is like comparing. Okay, for the comparison, we have to take the diagonal shape. Okay, so we'll just do along with it N1, N2, N3. No. Every shape has its own importance. Like this elliptical shape is only for the start and stop. So I have explained that yesterday. Okay, so only for the start and stop of the process. This is only for operations done. This is only for the parallelogram is only for the input and output. This is to check the conditions. So based on the condition checking, there will be an yes, there will be a no. That's why two outputs. Okay, two possible outputs. Then this is like the connector, and this is to control the flow from where to where it should go. Okay, so that's what it is. You can't use any shapes. Always the flowchart will be done. Only every shape has its own meaning. Okay. So here we have to compare. First thing is what? N1 greater than N2. That's what we have to compare. So N1 greater than N2. So that's a condition to check. So giving a question mark. So there can be two possibilities. One is one yes and one no. Okay. So if that is yes, again we have to check another condition. So again we should have another diagonal shape. Okay, diagonal shape to do the condition check. So again we are, if this is true, then again we are checking. Okay, so if that is yes, then we are checking N1 greater than N3 or not. Okay. So if that is true, we are thinking N1 is the largest. So to print the output, we should have, okay, it's already there. Okay, so that much is done. So then what it is, if this condition fails, yeah, just a flowchart. So if, okay, what happens, Saddam? Is there an issue? So if this condition fails, the N3 is the largest. Okay, so if this condition fails, okay, so that's the, again, this is for yes. N3. Okay, so the second one with respect to, okay, the no, okay, if this fails, what to be done, that is also done here. N1 is greater than N3 or not. If it fails, okay, with that means N3 is the largest. Then what it is, so this much is done. From here till here, that's done. So for this one, if this condition fails, okay, then only we are going to check N2 greater than N3 or not. Okay, so if this condition fails, okay, N1 greater than N2, okay, that's the condition. If this fails only, we are going here. So that's again another condition check. So the condition is like N2 greater than N3 or not. Okay, so N2 greater than N3 or not. Again, this will be having possible two outputs. Okay, so one is like yes or one is like no. So if that is yes, that's like N2 is the largest. N1 greater than N2. If that fails only, we are coming to this particular condition check. So that means N2 is already greater than N1 and N2 greater than N3 or not. Okay, so it's like N3 is the largest. Sorry, N2 is the largest. Okay, 1 second. Let me see in a better way I can do it or not. Hmm. Okay. Well, so the next thing is what if this condition fails? Okay, so if this condition fails, that is like print n3 is the largest. So we have to even give that as the output. So the no is there. Okay, so we have to connect that with the n3. Okay, let me see. Better than that, if I keep yes here. Yeah, like the else I have to print the n3 largest twice. Okay, like this one should be given twice. So I'm making it modular. That's also important. Yeah, will try. Okay, so accordingly, this one is like mm, sorry. Okay, so we'll just say so n1 greater than n2, then checking if yes, checking n1 greater than n3, n1 is the largest. Or else it's like n3 is the largest. Okay, so that is the else case. N3 is the largest. Then again, I'm checking if this condition fails, I'm checking okay whether N2 is greater than N3 or not. If yes, N2 is the largest. Yes, so if yes. And if no, okay, here also if that is false, then that is N3 is the largest. So we can make this one common now. That's why I rearranged. Okay, now if if the n1, suppose if this is 10, this is also 10, then this condition fails. I'm not giving greater than or equal to, less than or equal to something. So if this is greater than, okay, then if this is n1 is 11, n3 is 10, then only I can say n1 is the largest. Okay, so there is nothing like equal. Okay, so if we will like when you start with the programming, you can just try the same logic. Okay, it will work even for the equal numbers, so it will give the largest only. Okay, so now what it is, the output printing, like printing n1, n3, n2, everything is done. Now that is the stop. So that is also important. You have to end all the process. So the stop should be given with the same elliptical thing, same elliptical shape. So okay, so is this clear for you? Now is the logic clear for you? Starting with three numbers, first checking whether n1 is greater than n2 or not. So it's the logic building. Okay, so checking two numbers. So if n1 is greater than n2 only, we can say we can compare that with n3. Okay, n1 is greater than n2. So if this is true, then we are checking n1 is greater than the next number n3 or not. If so, we are telling n1 is the largest, then we are, sorry, that is stopping the process. Okay, so that's done. Suppose if this condition fails, then we are coming here. So this condition fails, that means n2 is the largest. So coming here and checking whether n2 is greater than n3 or not. Okay, so as per this one, n2 is greater than n1 if the condition fails. So coming here and checking n2 is greater than n3 or not again. If that is true, n2 is the largest. If that condition fails, n3 is the largest. Okay, so after that, coming to the end of the process. So is this logic clear for you? Yes or no? Yes or no? Hmm? So this is the way to write the algorithm. Okay, so we will see the next one. So again, that's a simple one, similar to this. So hereafter, we are not going with the natural language. So the programmers, that is something unnecessary. That's why we will go with the pseudocode and the flowchart only. Find something like, I'll just give, find number is positive, negative, or 0. Okay, so this is our next problem. So we have to write the algorithm to find a number positive, negative, whether if a number is positive, negative, or 0. So now you have to tell me the logic. So we'll go with the pseudocode. Okay, I'll start. Okay, then. Okay, we have to just read one number. So we can give any appropriate name for it. I'll just give that as only one number is there. Then how will you find, how can you say a number is positive? What's the thing to be checked there? What's the condition to be checked there? comparing, like if a number is greater than 0, well, that's the positive. Okay, so if less than 0, negative. So equal to 0 means it's neither positive or negative. That's what we can say. So the third step is like comparing. Okay, so we are going to compare. Yeah, yes, we are going to compare. So whenever there is something to compare, we'll go with if. Okay, so we are just checking if num greater than 0 or not. Okay, if so, what to do? What it means? We can just print num is positive or just print positive. Yeah. So if this is not true, okay, if this is not true, we have to go with the next condition check. So we have three conditions to check. In that case, we have to even check else if. Okay, else if this condition, next condition is true or not. So we are checking whether num is less than 0 or not. That's the next condition. Okay, so there again, what it is, print num is negative. Yeah. If both these condition fails, then that means what? Else. Okay. If these two conditions fail, that means that is 0. Okay. So I'll just print neither positive or negative. Okay. So in a better way, we are writing the 0. So that's the thing. So that's our solution, isn't it? So the logic is clear now. What to do, that is clear. Now the fourth step is ending. Stop. Okay, so this is what we have to do. It's again simple one. So we'll just quickly draw the flowchart. So we have to read just one number here. Then we have to check the condition. So always when that is the decision making or the condition checking, we have to go with the diagonal. So we have to check num greater than 0 or not. If yes, that's positive. Okay, so we have to print positive. If no, that's the next condition check. So if no, that is the next condition check. Okay, else if that is the next condition check. So again, we need another diagonal shape. So that is less than 0. So if that is true, that actually means num is negative. Then what it is? If this condition, okay, if this condition fails, num is negative. Okay, it's negative. Okay, so I didn't edit that properly. After this one, yeah, you can check any one condition. Num less than 0 also you can check first. No issues. Okay. So that is your choice. Like num less than 0 can be checked, num greater than 0 can be checked next. Okay, so I'll just give a 0 here. Positive, neither positive nor negative. That's the actual thing. I'll just keep that as 0. Have lesser space, that's right. Then the thing is like stop. So stopping the process. Okay, is that clear for you now? Is this much clear? So that's again one simple problem to solve, isn't it? Any doubt in this one? Any doubt till here? No, right? So we'll go with the next one. So we will find the sum of numbers. Okay, to find sum of 1 to, so I'm just starting from 1 to n. What is that n? That is user's choice. I'm keeping it like this. So now we have to find the solution for this problem. Okay, how can we build the logic? So I'll go with the pseudocode. So the requirements, so I'll just start with it, start. So now what's the requirement? Okay, what's the requirement here now? We should have the n value. Okay, so read n. Now, the next one. With the n, what to be done? We have to find the sum, isn't it? So I can say declare sum, or declaring sum in the sense a variable, okay, variable to store the actual sum value. What is the final sum? Or I can even say, in a better way, I can say sum equals 0. I'm just initializing it. Okay, so why this is important, I'll come to this point. Why the initialization? Initialization in the sense, we are taking one variable, assigning a value to it. Okay, so declaring means just having the variable. Initialization means having the variable as well as giving a value to it. So initialization of the variable, I'm just doing it so for a reason. I'll come to this point. Now, what exactly we have to do? We have the value n, so assume the n is 10. Okay, assume the n, I'm giving it as 10. So I have to find the sum from 1 to 10. Now, how to find it? What will you do? Sum and increment from 1. Okay. So initially what to be, okay, while loop, a loop. Okay, so every time what we have to do, from the 1, like I'm taking 1, okay, then the, like I'm taking 1, okay, so it's like, okay, so I'll just do it like this, 1, then what to do? 1 plus what to do? Yeah, sum plus 1. So I can just do it like sum plus 1. Okay, what is the sum value? I'm keeping it as 0 initially. So that what it is, why the initialization of variables are important, okay, um, in the sense, when you get the memory for it, like everything, every variable should get the memory. Inside the system's memory, it will get a space to hold the value, isn't it? So when any variable get the memory allocated somewhere inside the system's memory, okay, where exactly and all we'll see later. But as of now, every variable will get a space in the memory when the program execution happens. So this is like the variable getting the memory somewhere. Okay, we don't know exactly at which address or which place also. So it may contain some value. Okay, so that unknown value may be the output of the previous program. Okay, so it can be an integer value or it cannot be an integer value, sometimes non-readable. So maybe something will be there, sometimes it will be 0. We don't know what exactly is there. So there are chances that, like when we are doing some expression like this, so here we are doing sum plus 1. So for the first time, okay, first time when I am doing this, sum should be 0. So what if that contains already a 10? Okay, I'll get the wrong output, isn't it? So that's why I'm keeping this as 0 so that I won't end up with some erroneous output, wrong output. So instead of that, I'll just overwrite whatever is there inside the memory. So I told that's called as the garbage value. So those garbage values are overwritten with the 0. Okay, now I can say this is going to be right. Okay, so whenever like you are taking the same variable here as well as here. Okay, so whatever is on the right hand side will get evaluated and the result will be assigned to the variable on the left hand side. That is how the expressions will get evaluated. This will happen first. So when this happens first, this should be 0. When the sum value is taken, it should be 0 initially. So I have done the initialization. Now sum equals sum plus 1. So first one, like it starts from 1. That's done. After that, what should I do? Okay, I should increment this 1 to 2, isn't it? Don't you think the 1 to 2 is required? Okay, the increment should be done. So I can say something like this. Okay, num, another variable to do that. I can say num equals num plus 1. Okay, and then I can initialize. So num is another variable. Okay, sum is another variable. So I have done sum equals 0. Okay, num equals 0 also. Okay, num equals 1. Initializing that with the first number in this series. Okay, 1 to n only I have to find. So which is the first one? I'm taking that here. Instead of this one, I'll just give num. Okay. So now this is a generic one. So it's like, now it is like sum is 0, 0 plus num is 1. So 0 plus 1 is getting stored to the sum. Okay, 1 is getting stored to the sum. After that, when it comes here, num equals num plus 1. Num was already 1. 1 plus 1, it will become 2. Okay. So again, what I have to do? Again, I have to repeat these things. Why initializing some? See, Anil, I told, like whenever a variable is getting the memory, okay, it may contain some garbage value. Garbage value in the sense we don't know in the memory what exactly there will be. Okay, so every variable, when it gets the memory allocated, somewhere inside the system's memory, it's getting a space to hold the value. So initially, so in this type of expression, what it is, I'm taking the value of the variable, already existing value of the variable is taken here, and I'm doing the operation. Okay. So then only when I repeat the same step, so in the next iteration, like next iteration in the sense, I have to repeat this till where? Till the till the 10 value. Okay, till the n value. Whatever the user has given, till the num has to reach. Okay, num should reach the 10, then only I can stop this process. Okay, so this has to be repeated. Okay, always this has to be repeated. So that's why it made it as a generic one. Okay. So in this type of expression, I'm taking the already existing value of sum. Okay, and we are making sure that should be that is 0. By assigning 0, I'm making sure there is no garbage value and I won't get any wrong output. Okay, so initialization is important in this type of expressions like sum equal sum plus something, sum plus 1 or num equal num plus 1. In these type of things, initialization is important. We are making sure what is the expected value. Okay, initially it should be holding either 0 or in this case, it starts from 1. So I'm making it as initializing that with a 1. Okay. Is that clear? So that is as per our requirement. There is no rule. All the variables should be initialized. If you have to work with an expression like this, where it all takes the already existing value, okay, when this particular expression is evaluated for the first time, it shouldn't end up in any wrong output. That's why we are making sure this is 0, initializing it. And this is 1. Why? Because we are finding the sum from 1. That is our problem. So as per the requirement, we are just initializing the variables. Got it? Yes or no? Okay. So again, what it is, till where we have to repeat this, till when the num value reaches the 10. It has reached only 2. Okay, so we have to repeat this again and again and again. Okay, sorry. Mm. So it's like in the next time it will be, so already existing value of sum will be 1. 1 plus the num value, 1 plus 2, it will become 3. The sum is 3 now. And the num will become 2 plus 1. It also will become 3. Like this, it has to go till where? Till the num value, okay, less than or equal to n value. Till there, it has to reach, isn't it? So this is what we have to do. So to repeat this, instead of writing it 10 times, we can just write it only one time, and we can use something called as a loop. Okay, looping in the sense repeating an action. Like you can see, these two lines are repeated. Okay, if I want to find the sum till 10, I have to write these 10 times. Okay, instead of that, we are just doing it only once, and we are keeping it inside a loop. What is exactly loop and all, or what is the syntax for it and all, that we will see later in a detailed manner in the coming classes. Okay, so as of now, understand loops are to keep something in a repeated manner. Okay, so if if you have to repeat a step multiple times, okay, repeating multiple times, so you have to use the loop. There are two or three loops in C programming. So the loops are like for loop is there, okay, while loop is there, okay, we even have something called as the do while loop. Okay, so these are the loops that we are going to see later in our programming. So as of now, I'll go with one of the loops while. So all these three works based on the condition. Till the condition is true, it will keep on repeat the same thing. Okay, so I'll just keep it as while. Okay, while the condition is true. So this is how the while loop works, and we have to give the condition. So till the condition fails, it will keep on doing or repeating the set of operations. Okay, so I'll just keep this condition. So this is our condition to keep. So num less than or equal to n value. We have to do what? We have to repeat these two steps. Okay. So when it becomes like 10 less than or equal to 10, okay, till that it goes. When the num value will become 11, 11 less than or equal to 10, this condition fails if the input is 10. Okay, so at that time, it will come out of the loop. Okay, so this operation will stop. So that's what the loop is. Then what we have to do? We have to print the sum. So find the sum is our problem. So the solution is printing the sum. Okay, after that, that's the end or the stop. So now we have to draw the flowchart for this. It's a little different, isn't it? The loop is here. So we'll see how we can do it. So till the condition check hits the same thing. No. Then we have to declare or initialize the variables. Okay, so these type of operations should be kept in the rectangle. Okay, can we use loop also here? For loop also here. Yeah, you can use any loop. Okay, so for the convenience, I use the while loop. You can use any loop here. So as of now, we don't know the syntax for the for loop and all. Okay, that's why I didn't take the for loop. That works with a different way, isn't it? So if that is a while, just with one condition, it's working. Okay, that's the only reason. So whatever we can do with the for loop, we can even implement that using the while loop. Okay, so when it comes to the loops and all, we will see that. So the initialization is done. Now that is the loop. So here we are checking the condition. So condition check can be done using the diagonal shape. Less than or equal to. Okay, if that's the case, if I'm keeping num equal to n or not as the condition, if that's the case, it will these two lines will be evaluated. Okay, this operation will be done only when the num is 10. Okay, initially num is 1 only. Okay, so when it reaches like it is incrementing inside the loop. these two things will happen only inside the loop. So it has to reach the 10. Initially this is 1. So the condition fails. If I am keeping only equal to condition fails, these are not going to get operated. Okay. So less than or equal to n. Declaring n, I haven't done. In fact, what it is to read the n before that itself, the declaration of n should be there. I haven't keep that step. Like in detail, if you see, a lot of things will come in between. So that comes when the syntax comes. Okay. N equals 10 or reading the n. I have kept it as reading n. So this is like the example I have given. Okay. This entire thing is nothing but the example. So don't see that. Don't compare with that. If the n is 10, I was just giving the example. That's all. So according to what we are doing the flowchart, that is the pseudocode. This is the generic one. This is a case. Okay. This is a generic one. So we are keeping the condition. If the condition is true, we have to do two operations. These two operations we have to do. So the operation again, it will be inside the rectangle. Okay. That is for if the condition is true. And what is the next thing? It doesn't stop there, isn't it? Doesn't stop there, like it's a loop. So it's not just one time. So after this again, what to be done? Okay, after this again, what to be done? It's like it will go on repeating. So after doing this for one time, it's not stopping. It's going back and checking again if the condition is true. That's the loop. It's repeating. Okay, so we have to even show the loop here, like it's not just one time. So after doing it, it's again going back to the same condition check. Okay, so when this condition fails only, it will come out of the loop. Okay, so that is the no case. So then what we have to do? So when this condition fails and it comes out of the loop, then that is the final sum. So we are printing the sum. Then it's the stop. After every loop, yes. So after every, like I told, like initially it will be one, sum will be 0, num will be 1. Okay, so this is the first iteration. Okay, so when the loop runs for the first time, so 0 plus num value is 1. So 0 plus 1, it will become, some value will become 1. and the num value was 1, so 1 plus 1 it will become 2. Okay, so now sum is 1, num is 2. So when the loop runs for the next time, second time, so these values will be considered. Okay, so it will be like sum is already existing, sum is 1, 1 plus the num value is 2. So 1 plus 2 it will become 3. So now the sum value is 3, num value will be 2 plus 1, 3. Like it's getting updated for every iteration. Iteration in the sense whenever the loop runs. Okay. In flowchart, yes, it's getting updated here, right? Okay, this condition will be checked every time these operations are done. Again, it's going back and checking the condition. Okay, if the condition is still true, again it's coming here and again doing the operation. Okay, so this will go on till when? Till this condition fails. Isn't it? Are you not getting it? So every time, so this is the way in which we can show this is a loop. It's going back and checking every time. Okay, after the operation. So whatever I give in the rectangle, that is like operation. These are operations which are carried out. Okay, so every time it's coming and checking the condition. If the condition is true, sum will get updated, num also will get updated. Again, there it's going back and checking the num less than n or not, less than or equal to n or not. So if this condition fails only, it will come and print the sum. Getting? Are you getting? No need to give flow line for sum equals 0. Why? That is like after reading the n, I am declaring or initializing it. This is one assignment operation done. Okay, so this is one step done after reading the n value from the user. Okay, to store the values, I am initializing two variables. Okay, so this is like one operation done. Assignment is also one operation. In fact, this equal to is also called as assignment operator. That we will see later. Even though, understand, I'm assigning or keeping some values inside the variables. Okay, so that is one operation. That's why I kept that as a step in between. Okay, if this sum is not initialized, num is not initialized, I can't say this will end up in the correct output. So even this has an importance. Okay, we can't just have the variables. Initialization is important. Okay. So for the correctness of the output, this is important. That's why I kept that in between. It's not just the declaration of variables, it's initialization. Well, so this is the flowchart for this particular problem, that is to find the sum of 1 to n. Is this much clear for you? Yes or no? Now even we will see the printing of patterns, pattern printing. Okay, so now we have seen some other problems till here. I hope it's clear for everyone. If you have any doubt, you should ask. Okay, so these are the simple problems. Okay, how to find the how to do the logic building. That is what we have done. Now we will even see how to print the patterns. Okay, so while printing the patterns, always you have to keep that in mind. Okay, so we are printing row wise. Okay, so every time when you print something on your screen, system screen, how it is getting printed from left to right and from like after completing one line, it will come to the next line and printing. It can like I'm not telling it's completely impossible, but usually how it is, it's not going back and printing from the starting again, isn't it? So it's like completing one entire line in the sense that is one entire row. Okay, that is one row. So one line, that is one row, and horizontal manner, that is the row, and vertically, if we say, that's the columns. Okay, columns. So row wise only the whatever it is, anything, even if that's a document, it will get printed in a row wise manner, line by line only. So while working with the patterns, we have to keep that in mind. Okay, printing the patterns. So for example, if that's a pattern like this, you have to print 5 stars like this. Okay, so how will you print this one? Do you have any idea? Any idea how can you print this one? Do we need a loop here? So we can just do it like ask equivalent and all dot into the picture now. Okay, so if I want to print a pattern like if, okay, yeah. So what it is, so here also I'll just do like start. It's so simple. So hereafter I'll be going only with the pseudocode for the patterns. So start, then how many stars to be printed? Okay, so that I can read a value. Okay, read something like num or n. Then what it is, I have to just check the condition for what. Okay, so I can keep something like a count or something. Okay, so 5 times only it should get printed. I can just keep something like, okay, so I should have a variable. Yeah, or I'll just write it as num. Num is initialized or count. Count is the better one. Okay, count is equal to 0. So every time every time what should I do? Okay, I should do it like, okay, if the count is less than, okay, the count or what should I do? I should check the condition as, okay, so if it's one time checking only, we can, okay, if it's one time checking, then I should go with if, okay. If it's multiple time checking, I should go with while. So I'll just keep that as while. So while the count is less than n, okay. If the n is 5, okay, so in that case, so 0 to 5, okay, so 0, 1, 2, 3, 4. 5 times it has to do what? It has to print star. Okay, printing the star. So that's the thing. 5 times I'm printing the star, then I'm, so with the space, star with the space I'm printing. Then what? I can stop the thing. So stopping the pattern printing. So depending on the n given with a simple loop, I can just print this pattern. Okay, so it's just one row, so it is easy, isn't it? So is this clear for you? Is this much clear for you? That is very simple, right? So the next thing is like, what if I want to print something like this? Okay, so it's like 5 stars. Okay, 5 rows are there, 5 columns are there. Okay, so if that is a horizontal manner, that is the row. So every time when there is a pattern, you have to see that as rows and columns in a matrix way. Okay, so you have to just divide that into rows and columns. Okay. Okay, so I have 5 rows here, 5 columns here. Okay, it's like, so these are the column numbers. First column, second column, third column, like that. And these are the rows. First row, second row, then third, fourth, and fifth. Okay. Now in a similar way, how can we write the pseudocode for this one? How can we write? So starting, then you can take the number of rows. Okay, number of rows as the value. Okay, or to read from the user. How many rows should be there? So I'm keeping the variable name as a row. Okay, so how many rows should be there? That should be read. Then what to be done? Hmm? Okay, so in every row till where it's printing, that you have to see. Every time you have to see like in one row till where it's printing. So in every row here it's printing in the same manner. Okay, in all the rows it's printing only 5, which means what is the row value till there it's printing. Okay, so you should have a loop there to access the rows. So with respect to one row, okay, it's printing 5 columns, 5 column values. So for the column 1, so when it's like row 1, column 1, row 1, column 2, row 1, column 3, like that it's printing each star every time. So row 1, column 4, row 1, column 5. So taking one row, printing 5 for the 5 columns. Again, what it is taking the to control the or to access each row here, you should have one loop. Okay, so you should have a loop to control the rows. Okay, so again, from where to where the row value is coming. Okay, row 4i, column 4j. Okay, you can keep any what it is variable name. So from where to where the row is running, row from 1 to row 1 to in row value or the 1 to this particular value entered by the user. So 1 to whatever is the value entered by the user. So here I am keeping that as the row itself. Why? Because I have taken the variable name as row. Okay, number of rows only the variable name I have taken. So then again what it is, we have to run another loop to access the every like the row it is taking like, okay, let me take this as I. Okay, I for row, not to confuse you. Okay, so now what it is, I value will change from 1 2 3 4 5, isn't it? 1 to row value. Then with respect to each row we have to print the columns. So again with respect to each row, so there is another inner loop for every row. Okay, so that again runs from where to where? 1 to which value? Again, that is from 1 to row value only, isn't it? It's printing five stars every time. So it's again, so if that is the row 2 again, okay, it's printing 5 times. So 1 to row value, it's going to print. Okay, so what it is going to print? Printing the star. Okay, with respect to each row, it's printing. This inner loop is running. Okay, so if the I value, so the loop j, Okay. So I value from 1 to, for example, if that is 5, 1 to 5, 1 to 5, so I value will be initially 1. So accordingly, for that I value, this J loop will run for 5 times, 1 to 5. So every time when the J loop runs, it's printing the star. Okay. After that, what it is, after printing 5 stars, what to be done? The control should move from here to the next line. So what to do? What to do? We have to print the new line, isn't it? After printing with respect to one row, it has to, or it should come within it. It has to print the new line, isn't it? So after completing with respect to one row, it has to, the control has to come here and then it starts printing. Okay, so that's why with respect to when the inner loop is completing the printing, then it has to print the new line. So again, it will go back here. Okay, it will do the increment for the row. Okay, and then it will do accordingly. Again, this J loop will run for 5 times. It will print the star. Again, coming here, printing the new line comes here. And then what happens? The I value will be incremented. So from 2, it will become 3. Okay, then it has to happen again with the loops. Okay, up to what end? Up to the row value. Row if that is 5. So is this clear for you? Is this pattern clear for you? Yes or no? Okay. So we will see another pattern. So it's a right triangle pattern. Okay, so how to print this one? We will see. So here also we have to separate that into rows and columns. Okay, in the same manner, we have to separate that into rows and columns. So to access, so every time you have to see from where to where in a row, like you can see in the first row only 1 star, second row 2 stars, third row 3 stars, fourth row 4 stars. So here also after printing the first row only, the control will come to the second row. Then after printing the second row 2 stars only, control will come here. Okay, so we'll just see that. So here also we have to decide this pattern based on the number of rows. Okay, so you are reading the number of rows from the user. After that, what to be done? So you have to access the first row. Okay, so in that first row, how many stars to be printed? That will be decided by the second loop. So one loop to access the rows, one loop to access the columns with respect to each row. Okay, so one loop to access the rows. So I'm keeping it as it is. And the loop J, from where to where it should run? 1 to I value. You can see with respect to the column row value only, the column is actually, or the stars are actually getting printed. So whatever is the I value, those many stars will be getting printed. If the I value, if that is the row number 3, then the I value is 3. So that time 3 stars will be getting printed. Okay, so that is the only change we have to do here. Okay, so after printing for the first row, printing 1 to I value will be 1. Okay, row value will be 1. So printing the 1 star, after that we are printing the new line. So that much is done. Then coming back here, incrementing the row value will become 2. Then what it is, I value is 2 now. So J is from 1 to 2, which means 2 stars need to be printed. So printing this 2 stars, after that printing the new line, control comes here, like that it goes on, till where? Till the row value. Is that clear now? Okay. So we will see another pattern, like Again, that is triangle pattern, but inverted. Do you have any idea how to print this one? Any idea? So here also you need two loops, one to access the rows, one to access the columns. Okay, so you need the number of rows to control the pattern, like till where it should print. Okay, so how many rows should be there that we are reading from the user? After that, do you have any idea how to do it? So in the first row, you are printing, if the n value is 4, you are printing 4 stars. Okay, in the second row, you are printing 3. Then third row, 2. Yeah. Okay, so the first row, in the first row, what it should be? It should be from row value to, okay, initially I value should be row. Okay, so whatever is the row value, n2, and then it should be decremented. Okay, every time when the loop runs, we are decreasing from the row value. So initially, if the row value is 4, in the next iteration, like for the first iteration, it is taking 4. Okay. So when the loop runs like 1 to 4, so 1 to 4 in the sense 4 stars are getting printed. Okay, 1, 2, 3, 4. 4 stars are getting printed when the I value like this printing starts from here. Okay, so I value is what here now? I is nothing but from row. So that is 4 now. Okay, okay. So printing starts here. Then what it is? 1 to 4 stars are getting printed. Okay, 4 stars are getting printed. After that, control comes here. Okay, so which means new line will be printed. Control comes here. Then again going back and doing the decrement, I value will become 3 now. Okay, now what it is coming here, I'm printing 1 to 3 stars. Okay, so printing 1 to 3 stars, printing the new line. Control comes here. Okay, again going back, doing the decrement. Okay, so like that it goes on. Is that clear for everyone? Yes or no? Only one change we have done. Then the pattern is inverted. Okay. Then I'll show one another pattern. With this pattern only we are going to implement that also. So this is the pattern we have to print. So understand these are the, like whatever I'm doing here, star and a space after it. Okay, that's the same space here. Okay, the star and a space getting printed. Like that you have to consider it. So how to print this pattern? Any idea? Any idea? Anyone? So here if you see, okay, good. 3 loops are required, fine. Here if you see, you can see there is like a hidden pattern here. Okay, I'll just show. There is like a pattern of spaces here. Before the actual pattern, there is a pattern of spaces. Okay, it's like this. So if you print the spaces only, then you can print the star. If you print the spaces in the first row only, you can print the star then. Okay, did you get it? Okay, so if the star spaces are printed, then only you can print the first star. So then again here, so if it's like what exactly? So in this case, how many rows are there? If you see, the number of rows will be like not 4. Yes. Sorry, I asked for rows, right? Yes, 4 rows are there. The columns are 7. Okay, sorry for that. Okay, so this is how exactly our pattern is. Okay, so it's like 1, 2, 3, 4, 5, 6, and 7. Okay, so 1, 3, 4, 5, 6, 7. 7 columns are there and sorry, 4 rows are there and 7 columns are there. Okay, so this is what we have to print. So when it comes here, like 1, 2, 3 spaces are getting printed, then only the fourth one as a star. Then coming here, 1, 2 spaces are getting printed, then only third one is star. And we are printing 2 stars here. 2 spaces, 2 stars. 1 space, then 3 stars. Okay, no space, all 4 stars. Okay, so here also we are reading a value as n. Okay, we are reading how many rows should be there. Okay, so we are keeping that as n or a row. We can keep as per your wish. How many rows are there? You are just keeping that here. In case we should consider like inside this space, like I told, that should come with the star. Okay, no extra space is getting printed here. So along with the star, the one space is getting printed. That is only considered here. Okay, so here we have to even print the spaces. That should be considered. Without that, we can't print the first one. Okay, so now how to implement it? How to do this? So one loop to control the rows. So I'm considering I for row and we will see. So to control the row, so the row should go from where to where? I'll keep that as from 1 to n itself. 1 to n. After that, with respect to one row, I have to print the space first, then only I can print the star. So loop to print the space, I'll keep that as j. Okay, loop, sorry. Okay, I'll keep that as j. Okay, so printing the space. So 3 spaces should be printed first. So what to do now? Row value, suppose if n value is 4, okay, if n is 4, while coming here, like I value is 1, sorry, 1. And now what it is, j should print like it should be 3. Okay, how can I reach to the 3? I can keep it like, okay, 1 to n minus 1 or n minus 1 to 1. Okay, only the requirement here is what? I should get it as 3. Okay, so I'll just keep it as 1 to n minus, okay, n minus row value. Okay, row value is given. So row value is initially 1. Okay, so row values initially, I'm sorry, I values initially 1. So n is nothing but 4. 4 minus 1, 3. 1 to 3. So 1, 2, 3. For that, it should print the space. Space. Okay. Then only I can print the. So I'll print the star using K loop. So from where to where it should go? For the row 1, it should print only one time. For the second row, 2 times. Third row, 3 times. So I can say it as 1 to I. Whatever is the row value, those many times the stars are getting printed. So print star. Okay. So then printing the new line. So first time when it runs, it will print 3 spaces, then print the star, printing the new line. So the control comes here. Okay, then in the next iteration, I value will become 2, j value will become like 1 to n minus I. N is 4, 4 minus 2 is nothing but 2. So 1 to 2 times. Okay, so 2 times it's going to print the space, then 2 times, so 1 to I value is 2 now, so 2 times printing the star. Fine, this will work. Okay, so is this clear for everyone? Yes or no? Okay, so you can try some patterns. I'll just give the patterns. Okay, something like 1. Okay, so whichever are need to be done as the practice works or the class works, I'll just send it in the LMS. Okay, as the class work, I'll just send it. We can just try it. Yeah, I'm printing that space here. Okay, I'm printing that space here along with it. Along with the star, one space will get printed like that. Well, I'll give the classworks in the LMS, so please check it. Okay, and then do you have any doubt in today's session? Any doubt, anyone? Okay. If so, we'll wind up the session.